Alright, so we need to go ahead and open up our notebooks. We are going to start our function unit. So, on this one, our very first thing, we're going to 7.1. We are going to skip over that part. It was an online thing. It was supposed to be set. We're going to go ahead and skip that. Miss Majors is ahead of us. And she said, really didn't think we got as much use out of it. So, because of everything that we've been missing, we're just going to move forward. First thing you notice is what I do on OneNote, you will not see everything in your notebook. We have other examples up here. The purpose is you focusing, participating up here, and then I can also call some people up to come and do some work up here. So, first thing that we are going to work on is relations and functions. So, describe the relationship between the inputs and outputs of each diagram, and then we're going to complete the diagram. So we're going to look at this first one. And this one is not in your notebook yet. So don't worry, don't be looking for that thing today. But let's look at it. So I have the input of 1, and the output is 1. Input of 2, the output is 4. The input is 3, the output is 9. The input is 5, the output is 25. What do you think is the rule? What's the relationship happening between my input to my output? Ainsley?
It's going up by 5. It's going up by 1 each time.
Okay, my inputs might, well, no, what do you mean? Okay, so maybe most of the time we need something that's going to happen every single time. Right? Okay, we'll multiply the input by itself. Wait, put that away so I know you're focusing on math. So, our input is being multiplied by itself, and mainly we can say that is, I'm going to say x squared, the exponent. You put that on there, it tells me how many times I times by that. So, x squared means x times x. So, I have 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 5 times 5 is 25. So, if I put in 8, what should come out? Okay, 64 would come out. And then I put in a blank number and 81 came out. What was that blank number?
9. You do.
Yeah, you guys got this. Pretty good. Here's my question on this first one. If I put in 5, can anything besides 25 come out?
55. No.
And why not? You're right. Why no? Why is the only thing that can come out is 25?
Are you doing 5? Are you on?
Yep.
Just what it is.
I won.
Because what? Because of the
Input.
because of the rule, right? Yeah. On this one, our rule is we take the number times itself. If I put 2 in, how many answers are going to come out?
1.
Only 1. Okay? The answer will come out will be 4. Well, let's look at the second one. The inputs were blueberry, lemon, apple. The outputs were blue, yellow, red. So I put in a blueberry, and a blue came out. I put in lemon, yellow came out. I put in apple, yellow came out. I put in apple, red came out.
Orange.
Green.
Green could come out. Parker, you don't need to left
The
up.
last one's going to be green. No, it's going to be orange.
So, the last one would be green. Why did you guys come up with green?
Because you haven't used it yet.
Because what?
Because you haven't used it yet.
But I haven't used black. I haven't used purple. Why did green come out?
Because
Another color of apple.
It's another color of apple. Apples can be yellow, they can be red, they can be green. So what do you think the relationship is here? What is the relationship?
I have.
Oh, guys, conversation should be up here. Here, we are. Focus on this. What is my relationship between the inputs and outputs? Colors.
They're all types of fruit.
Colors of the fruit. Okay? So this is important than what you said though. The color of the fruit. So if I put in blueberry, it's blue. If I put in a lemon, it's yellow. If I put in an apple, apples are yellow, they are red, they are green. So more than one answer can come out. But then I see there's a blank and green came out. Okay? I could put grape, but if I did...
Then it would have been really apple. Why?
Good.
Hold on. Listening. Guys, 5 to stop for people. I'm just going to mark your planners. Okay, Molly?
Can you put a line? Line for green?
Line, why would that be better than saying grape?
Because grapes can be purple and red.
Yeah, so if I had grape here, I'd probably have to have a couple more lines that come off. Because according to this, when I put in grape, green's going to come out. But if I put a grape in, purple could come out, or red could come out. So I don't really want to use grape. I want something that's only green, and so a line would be a good example. What was the difference between these two? There's a couple things that we had different. What were they?
Oh.
Wait.
The apple went to like 3.
Okay, on this one, our input went to multiple outputs. That's one of the biggest differences. There's one other thing that we really wanted you guys to see.
It's talking about fruit.
Compared to
Vegetables.
numbers. You're right. The first one was numbers and more of a math problem. And this one was with words. Parker, I need you either focusing or I'm going to have to mark you down and move you. Okay? Huh? Okay, let's focus then. Okay, open up your foldables to the vocabulary.
Foldable is the most genius invention since.
So if we're going in here, should open up to this first one for me. Alright, so they're going to give us a couple definitions, some important things that we have to know. First, ordered pairs. We always write our ordered pairs, like on a coordinate graph, we always write them as X and Y. But ordered pairs can be used to show me inputs and outputs. If I gave you the coordinates 0, 1, 1, 2, 2, 4, you would be able to identify my input numbers are my X coordinates. So my input is 0, 1, 2. This is actually going to be what I can do down here, and you'll see. Output would be my Y's, 1, 2, and 4. Relation pairs inputs with outputs. So a relation puts the inputs with the outputs. Relation can be represented by ordered pairs or mapping diagrams. So here's what just happened. Up here was my 3 ordered pairs, 0, 1, 1, 2, 2, 4. So we have them right here. We can identify something as ordered pairs, but then I can take my ordered pairs and I can put them in a mapping diagram. If 0 was my input, which it is here, it went to 1. So I put 1 on my output and I draw a line from 0 to 1. Then I go from 1 to 2 and 2 to 4. That becomes our mapping diagram. Okay? This is a mapping diagram, just like these two were. In our example, you are going to work on this together. The first one, we have 2 plays, play A and play B. For each diagram, and this is one that I think we make little mistakes on, for each diagram, how many outputs does each input have? Not how many outputs there are, but how many outputs are there for each input? So you're going to have 2 answers on this. We're going to say for play A and play B. So let's look at just play A for now. When input is my tickets, the output is the cost. So when I buy 1 ticket, it costs $8. I buy 2 tickets, it costs $16. I buy 3 tickets, it costs $24. I bought 4 tickets, it costs $32. Okay, so looking at this, Zachary, opening up your foldable so you're with us. How many outputs does each input have?
Whoa. 2. 4. 4. No, there's 1, 2 or 4 is the one out, isn't it?
Say that again, Molly, louder.
There's only one input, or like the one input goes to one output. There's only one output.
Good. Now, the ones that said 4, what you did was you identified how many outputs we had. But the question is, for every input number, how many outputs does it go to? And like Molly was just explaining, for this one, it only went to one number. The 2 only went to one number. The 3 only went to one number. So for A, we are going to say 1 output per input. So yeah, we have 1 output per every input. Go ahead and make sure you write this into your notebook or your little folder. No, you should be on the vocabulary.
Do you have a staple remover?
Oh!
Okay, how about B? Let's look at play B. I'm going to pause the video. I'm going to give you about 30 seconds. I really do want you to talk to your neighbors. But I want you to talk to them about this, not other things. But how many outputs are there for my input numbers? Okay. So, turn and talk to your neighbor about it. Alright, who can give me the answer? What do they think? This one's a little bit trickier. Wade, what do you got for us?
I think it's plus.
Nope. You can say?
Isn't there one input for every 2 outputs?
Yeah, that's what I
No.
meant. That's not what I meant.
Yeah, it changes.
It changes, right?
Yeah.
So let's identify that first. It's going to change. So I'm going to say, very first thing, how do I want to say this? I felt like I did that.
There's 6 outputs. Playing in the body and no muscle.
So you said it changes. We're going to say it varies from what? What's the smallest one?
2.
2. Okay, I heard that. If I look, this number 1 went to 2 different numbers. So it varies from 2 to, which one had 4? Now the 3 tickets went to 12, 16, 20, 24. So it ranges between, varies from 2 to 4 outputs. That's what I meant. So let's go to this next question. Based off this, what about the price of the tickets? So in play A, when I bought 1 ticket, it cost me $8. When I bought 2 tickets, I spent $16. 3 tickets, I spent $24. What's the price of the tickets for A? What would be the price of my tickets for A? Miles? How'd you get $8? Yeah, the output is going up by 8. So $8 per ticket. An easy thing is, since each input went out to only 1 output, when I bought 1, it equaled 8. So I could have been able to see there. Or I could have divided my output by my input. 16 divided by 2 is 8. So each one costs 8. But B isn't as simple.
It varies.
The output's going up by 4. I like that you see that. 4, 8, 12, 20, 24. But what about the price per ticket?
Is it decimal?
It varies.
It's going to vary. How do I know it's varying?
Because
Well, we're going to know it's varying because my input, if I bought 1 ticket, it costs $4. Or I bought 1 ticket and they charged me $8. When I go to the stand where they just like, $4 fee, $8 fee, $8 fee, $4 fee. Maybe it's child adult tickets. Maybe
The
it's
elders. The elders.
ooh, maybe there's a senior citizen. Maybe it's location. Maybe this is a place where we're going in. If you sit up front, it costs more than if you sit in the balcony. So we're going to say the prices vary. And we have to identify how much. So we're going to say, oops, I want to use blue. So we're going to say our price varies from $4 to what? $4 to how much?
8.
I heard it. 8, not 24. 24 is the total cost, but for one ticket, $4 to $8 per ticket. Because of this, a person buys 4 tickets to each play. Can I determine the cost for all 8 tickets? Well, let's just do it at this first part. Can I decide how much would 4 tickets cost to go to play A? Huh? I bought 4 tickets to play A. What's going on? I'm taking Eli, Bennett, and Jude. So I had to buy 4 tickets. So it cost me how much? How'd you get $16, Sierra?
Because I did four times.
4 tickets. They cost $4 a piece. So I know for me to go with 4 people or 4 people to go, it's going to cost me $16.
Yep.
Okay, so for play B, I bought 4 tickets to play B. How much is that going to cost? Will I have an exact answer?
No.
What?
Yeah.
Maybe.
The senior citizens discount. Yeah.
This one, it's going to continue to vary. So, how much do you think it's going to cost me when it varies? I'm going to say between. How much is the cheapest I have? No. If I bought 4 tickets to the second play, what's the cheapest it would have cost me? Per ticket?
Like 20.
24.
Well, how'd you get 16, Parker? Okay, so the minimum, if the tickets cost $4, 4 times 4 was 16.
2. Very.
And
Over 24.
but the most tickets cost were $8. So if I bought 4 tickets at $8, it's going to be $32. Then they said, can I determine how much I'm going to spend if I buy 8 tickets? Can I find that exact answer? No, I can't. Because play B varies. Oh, you got a question or something?
Yeah, I have a question about A. How'd you get 16?
Because,
I know, but like,
oh,
it literally shows me, like,
because we screwed up. It doesn't cost $4. How much does a ticket cost?
8.
8. Thank you. I like that you asked that. So, 4 tickets. Each ticket cost $8.
24.
So it should have equaled
32.
$32. Sorry, we used the price from that first one. Good catch, Molly. And what else? I think you were about to say, Molly. How else did we know it had to be 32? If we would have looked back at our mapping graph, 4 tickets was 32. This one in your notebook. I don't think so. Okay, next few up here, not in there. Here's what I need us to do. This won't take long. We need to write these. Your folder boss, I know you're following along. We're going to take these from mapping diagrams into ordered pairs. So when I look at the first one, A, and I list out the ordered pairs, what would be one set of them? What would be one of the first ones? Ainsley?
1 and 3.
Yeah, so when we take our mapping diagram, you have to do this today in your homework. I'm going to say 1 is X, 3 is Y. What would be the other ordered pairs?
2 and 6, 3 and 9, 4 and 12.
2 to 6, 3 to 9, 4 to 12.
Parentheses, 4, comma, 12,
Okay, not too hard. Question on this one.
comma, space.
Could my input go to more than one output on this one?
No.
No, it only went from one input to one output.
But what about tap?
Let's look at B. Okay, on B, what would be my coordinates? Parker, let's put that away.
0, 0,
And be
2,
focusing up
1,
here.
2, negative 2, 4, 4.
Say it again.
I said 0, 0,
0, 0,
2, 1, 2, negative 2. Is that how you
2, 1, 2 to negative 2,
and then 2 to negative 2. I mean 4.
and 4 to negative 3. Alright, so those are right in my coordinates. We're going to come back to this in just a second. We have this function machine. On this one, when I put Phoenix in, what is Phoenix, Denver, Jefferson City? What? Before, not the answer. What are these?
They're cities.
Something more specific.
Lincoln is in
Places.
the capital. The things that are stars on a map.
Yeah, those things.
Alright, so when I put in, when we put in Phoenix, what comes out?
Arizona.
But how do you know that?
How do you know Phoenix goes to
I don't
Arizona?
study that stuff.
Because it's the capital.
Because Phoenix is the capital of Arizona. So if I put Denver in, Denver is the capital of. Do you know Jeff City is the capital of?
Missouri.
I did not know that.
Juneau is the capital of
Kansas City.
Alaska.
You're welcome, guys.
Wait, I didn't know that.
Lincoln is the capital of Washington.
Lincoln. I forgot Alaska is a state. So on this one, guys, on this one, if I put in the capital, can I get more than one output? No, I can only go to one. But let's look at this one. If I put in Missouri on this one,
Oh, Kansas City.
it's a state, and let's say Kansas City came out. Let's say
Ottawa.
Liberty
Washington.
came out.
Washington.
Let's say Lake of the Ozarks.
It's just a lake.
What?
Forget. Where is Lake of the Ozarks?
It's like in between
it's
St.
a lake.
Louis, Missouri.
So,
Hey, Sean.
Hi, Sean.
okay, so if Missouri came in, and Kansas City came out, Liberty came out, Lake of the Ozarks came out. So obviously when we did this one, we have more than one output for my input. But what would have been kind of the rule? What would have been the relationship?
Had to be in Missouri.
Yeah, it's locations in Missouri. So if I had Kansas go in, Topeka could have came out. What else could have came out?
Ottawa.
No,
Ottawa. A-T-T-A.
DeSoto.
My dad was there.
Is that in
DeSoto.
Kansas?
DeSoto. Oh,
A, how'd you spell A?
No, O-T-T-A. DAW.
License on mine.
Welcome to Ohio.
Ryan, watch out.
DeSoto. Overland Park.
Alright, so Overland Park, oh my goodness. We would list places that are in Kansas. We do the same thing in Nebraska and Iowa and Alaska. When we do this, do we have only one output for each input?
Yep. Wait, no.
No, we can have multiple ones. Okay, so this is important. This is all going to kind of tie in together now. In your notebook, the one page that is orange, it should be right up top of your planner. You put it in, it says definition of a function. Alright, notebook. And characteristics of a function. We're going to put this in right now. You need to be writing down definition of a function. A function is where each input has one and only one output. So, in order for me to say something is a function, it needs to have one input go to one output. I can have two inputs go to the same output, but the input can only have one answer. Only one answer. Characteristics of a function. So I'm just going to shrink this down a little bit. Characteristics of a function. What we're going to put in here is how we can check it on a graph. And the way I will do this is I'm going to use the pencil test.
I mean, so laughing from the back. I feel like that.
Okay. The pencil test. The way we do the pencil test.
Pencil test.
Guys.
Guys, stop.
The way we do our pencil test is when we look. You should draw this in yours. When I have a graph, and we're going to look at a line. Wait. Parker, what? Last time I'm going to stop class because you're talking. You have the choice. You can either follow along or I'm going to mark you and send you out. Okay? Characteristics of a function. We should have the graph, and I'm going to look at my line. And the pencil test is you just mainly take a pencil and you're going to hold it vertical. And you're just going to work from left to right across your graph. And it can only cross the line at one spot at a time. Okay? So,
Can I do a pen test?
cross only one place at a time. So when I looked at this, once again, here's my green line, and when I go across there, I can see, even if I mark at this spot, it is only at that one spot. It's not crossing any other parts of the line. Because of that, you would say this is a function. The second one we'll try
Wait, I don't get.
is if I had something graphed like this, and I did that same pencil test, and I went across. I looked vertical, and I worked left to right across there. I would see that my pencil would touch here and here at the same time. Because it doesn't, Ainsley, stop talking, please. Let's focus on that. Take it. Turn it face forward. You should be turned sideways looking at that. When I do my pencil test, I'm going to touch here and here on my line. Since it's crossing 2 points at the same time, it is not a function. Okay, we're going to try and put most of this together now. Now, we've looked at a lot of these little graphs, these mapping diagrams. We're going to go back over them and see, can we identify if they're a function or not? Right now, they've been a relation. There's been some way that the input became an output. But, according to our definition, the input can only go to one output. Okay? The output might have more than one input that comes to it, but the input can only go to one output. If I look at this example, and I had -9, it goes to 0. It only had one output. -2 only has one output. It can only go to 5. 5 has only one output. It can only go to 10. 12 has one output. It can only go to 10. Because of this, we would call this one a function. When I look at this one, and I see that -2 goes to only 4. -1 goes to only 3. 0 went to 5, and it went to 6. Because that input went to two places. Sean, turn, face forward. You can do your work. Because my input went to two different outputs, we say it is not a function. So if your input goes to more than one output, it's not a function. But on the first one, A, they all went to just one output, it's a function. So let's go back up to our first example. Let's work through this. Our very first one on A. Would this one be considered a function or not on A? Right here. Yeah. Every input had only one output. So A is a function. How about B? Why is it not a function? Zachary?
Because Apple can go to multiple colors or outputs.
Perfect. Apple went to more than one output, so it's not a function. We go to our plays. On play A, right here. Is this a function or not a function?
How can we know if it's not a function? Oh my god.
Okay, that's what we're discussing. It's a function if your input numbers only go to one output. So 1 went to 8. When I put in 1, the only answer I can get is 8. When we looked at this example, when I put blueberry in, the only answer I could get was blueberry. When I did lemon, only yellow came up. But when I said apple, my answer could have been yellow, it could have came out red, it could have came out green. Because my input could go to more than one answer, it is not a function. Where over here, when I put in 3, 9 is the only thing that could come out. 8, 64 is the only thing. So if my input can only go to one output, it's a function.
It's not individually, it's a whole paragraph.
Yep, it's going to be for the whole thing. So if we look at play A, you said it should be a function. Every input only goes to one output. On play B, is it a function or not a function?
Not function.
Why is it not a function?
The tickets vary from different.
Good. They go to different ones. One went to 4, one went to 8. So it varies. So this one is not a function. Wait, have your planner out. Go throw it in the trash can. I'm gonna mark you now. Parker, what do you need?
Blue.
For We'll get that. Wait, you can always get your stuff and you can leave. If you go to this door walls, come to me later. Right here, we can go through here. Okay, park it. We don't need blue right now because we're doing this. Okay, you can do that a little bit later. Okay, looking at A. Would this have been a function or not a function? What?
I didn't say anything.
Function.
Oh, something.
Always leaving.
Function.
Into the same
Function.
word.
It's a function.
I'll go get his plan and stuff
Function.
later. It is a function. B. Avery? Why is it not a function? Good. How about our function machine with the capitals to the states?
Function.
Function.
But the second one,
How about our second one?
Hold on, I want to do that.
because Kansas.
Function, not function. Yeah, because it only goes to one.
No.
Kansas goes
Oh,
to
Missouri went to Kansas City. It went to Liberty. It went to Lake Rosa.
Kansas went to
Yeah.
Topeka.
So,
I didn't read it. I just saw
listen up. Here's what you're going to do.
Reading is key.
You have two things that we're going to finish up with now. First, this thing. Whoops. I'm going to give everyone this piece of paper. What? Oh. What you are going to do is you're going to take this and you're going to cut all these little cards off. This is a card sort. Okay. On the page where we had definition of a function, we're going to glue in our two sorts. Now, some people put something else there. If you did, just get to the next blank page in your notebook and do it on that page. It's okay. But you can. If you don't want to cut that part up, you're going to have to cut all the sorts. So if you want to write function, not a function, not do that, and that's not a big deal. But you will cut all these cards out, and we're going to put them where do we think they belong. Are they functions? Are they not functions? That is part of what you have to get done. The second part is your homework. Your homework. If you turn to your homework page, for tomorrow, this is the part that I will take a grade on. This is what you can get late work on. You have 3 problems. On the 3 problems, it says, list the ordered pairs shown in the mapping diagram. Then determine the relation function. So for this one, I have to list out the ordered pairs and say, is it a function or not a function? List the ordered pairs. Function, not a function. This one, describe the relationship between the input and output. So kind of when we made those rules. Then complete the diagram. We'll fill in the missing blanks. Is there more than one answer possible? And then the last one is you be a teacher. You're going to read the scenario and respond to it. So I'm going to come around. 2 things to work on.